Hello there, Will Padillo here, and welcome to this series on VR development in Unity. This is going to be focused on Unity's new XR system, as well as using the Oculus Quest. I'm not going to be covering the basic project settings and hardware setup, since VR with Andrew has a very good series on that. I'll link to it in the description below. This particular video is going to be diving straight into getting input from the controllers, and doing so in a way that is very simple and extensible and doesn't couple together a bunch of other features that we don't necessarily want. So starting out, we're going to be creating a very absolutely bare bones camera rig. So I'm going to create in the hierarchy, right click, go to XR, and get our room scale rig here. And I'm going to open this up. And these parts, the XR rig, the camera rig, offset, leave those. Those are fine as they are. So is the main camera. Actually, before anything else, I'm just going to make sure that this works. So just verify that my Oculus Quest, the device, is connected, and that if I put the headset on, I am in the... I have the Oculus link enabled. And that has to be done when you open up the Oculus Quest, going into settings and setting it there. So anyway, if all of the hardware is set up correctly, then when I press play, I should be able to look around with my camera, and I'll see some lines coming out of where my hands are. So first thing is I want to get rid of all these line interactors and that kind of thing, because we'll be creating our own systems for all this stuff so that we can control exactly how it works. So in each of these controllers, I'll see if I can get both of them at once, and I will remove the XR interactor line visual and also the line renderer. Just remove that component and remove the XR ray interactor. And so that's right there at the minimum. And then next, also want to create a ground on the scene so we can see where we're standing. So we'll just go game object, create 3D object plane, and I'm going to zero out this location. Next, I want to be able to see where my hands are, especially since I got rid of those lines. So I'm going to create an empty game object and call it model. And then underneath that, I'm going to create a 3D object cube, and the reason I'm structuring it this way is so that I can very easily swap out this model with anything else. So right now my model is just going to be a basic cube, and I'm going to set is_trigger to is_trigger so that it's not running into things, and I'm going to shrink it way down so my head isn't inside of it, and I'm going to set the right hand up the same way. So create a model and then a cube inside there, shrink it down, and set it to trigger. Okay, so now when I run the game, and I look inside here, if I pick up my controllers, I can see my left hand and then my right hand over here. Now, one thing I'm also going to go ahead and add is to make it visible right away which hand is which. Now, in Unity, I can tell because they're just labeled left hand and right hand, but the player might not be able to see that. With the Quest, you can kind of, the controllers are not symmetrical, so you can feel which hand is which, but in some other headsets, it can be hard to tell, and especially the Vive will sometimes randomly swap the hands when you start out. So sometimes having a little bit of color on this can be helpful, or something asymmetrical in the game can be helpful to let the players see which is which. So I'm going to create a couple of materials. I'll just make a red material, set that to red, and then create a blue material. And set the albedo right here, zero that to set this to blue, and then on the left hand, just bring that in, and same on the right hand, just bring the red material onto the mesh renderer. So now, when I run the game, I can nice and visually easy see which hand is which. This is a nice kind of default setup right here, and then once I get more complex hands, maybe something that can open and close, I'll just replace these cubes out for those. Now, one thing I'm also noticing right now is the cube disappears when it gets close to my face, and that is because of a cutoff distance set on the camera. So I'm going to go ahead and fix that right now. So on the main camera, the camera component, yeah, this is the clipping plane right here. I'm going to shrink this way down to 0.01, and also just so to save on performance a little, I'm going to shorten the far distance. We can always change these and make this further out as needed. So now when I go back into VR and I bring an object close to my face, I can, yeah, things don't just clip out. And this is nice if you want to inspect things up close. Alright, so that's enough for my basic setup. Next, I want to be able to get input from each of these controllers. Now, Unity's XR system has some built-in ways using direct interactables and other kind of systems built in. Although having worked with those a little bit, I find they couple a lot of things together that don't always go together, and also sometimes it's better to just get input that you can then use however you want. One of them is if you want a keyboard-controlled character and a VR character and an AI character to all work the same way, just have the input systems different and then have the rest of the logic the same. I find it much more helpful to use a Unity event-based system. So I'm going to be ignoring some of the built-in interactable stuff and just getting input from scratch. So to start off, I'm going to create a new C# script, and I will call this just XR input. Attach these for now to the controllers directly. Later on, when things get more complicated, I'll be putting them on specific systems. And I noticed for some reason there's 2 of these attached. I'll just get rid of one of those. Okay, and now open that up. And I'll get rid of some of this boilerplate that Unity so helpfully generates automatically. Get rid of those. And we're going to be using the XR controller, so I'll need to get a reference to that. So I'm going to type in serialize field and XR controller. And Unity doesn't really know what this is right now, so I need to add a using statement using unityengine.xr.interaction.toolkit right there. And now I can drag in those references. Just drag that there, right-hand controller into itself like that. Now I'll start by just checking for a trigger press as a test before we start adding versatility to this. So private void update, create a temporary variable, bool is pressed, and controller dot input device dot try get feature value, and in here we'll be using common usages dot trigger button, and then out is pressed. And then right here I'll just say debug.log. Actually, I'll just say if is pressed, debug.log, trigger pressed. Okay, I'm going to test to verify this works, and then just kind of go over and explain what's happening in this particular line right here. Now, one thing that can be helpful in testing is to bring up the window and analysis and XR interaction debugger. And the first thing that we should see is in our input devices, we need to be able to see all these left and right hand controllers. If these are not showing up, then then that means that Oculus is not detecting that controller. The next thing is we should be able to see whether this trigger is pressed or not. So right now here we're looking for the trigger button, and when I press it, it should switch between true and false. So if that's not running, that's not any issue with the code. That's a connectivity issue. So next, if we look in this console window, we'll see it's I have it just saying whether it's pressed or not right now. So when I have the trigger pressed, then true, it's printing true. When I'm not pressed, it is printing false. Good, so that's our little test right there to verify we're actually getting something. So now to take a little look at this line right here. So we're getting access to the controller, getting the input device from it. Caching this doesn't really seem to work, so just, use them both. And then we'll be using this try get whether a particular button is pressed. We'll be using the common usages and checking for the trigger button. The trigger button is just a Boolean, true or false, whether the trigger is pressed or not. There is another one, I think, if I just look for trigger, that'll get a floating point between 0 and 1. Saying how pressed it is. For now, we'll just be using the Booleans. And then it also takes an out parameter, which basically you pass it in, and then it mutates the value of whatever gets passed in, kind of like working with raycasts. Rather than printing right here, I want a different script to be able to know whether or not this trigger is being pressed or not. So for that, I'm going to create a serialized field, Unity event, and for now I'll just call it on trigger pressed. And for that, I'll be needing to add the Unity events. So there, so we're adding using UnityEngine.events, also UnityEngine.xr, and so now in here, instead of just printing the console right there, I will just say if is pressed on trigger pressed dot invoke, like that. And now, so now we have this Unity event show up. And now I'm going to create a object that I'll just use for debugging purposes. So create empty game object debug, create a new script, C# print to console, and I'll attach that to debug. And then go inside of here, public void print string message. This is just a general purpose test script that we're writing. And inside here, debug.log message. Okay. Now, on these inputs, so the left hand, I can just drop in this debug here, look this print to console, print, and here I'll say left trigger pressed. On the right hand controller, I'll just call that debug again, and print to console, print message, right trigger pressed. Okay. And now when I run the game and I look inside the console, again, nothing's happening. That's because I'm not actually wearing my headset right now. So just to be able to see the console while also running the game, the Oculus has a little camera right above the eyes. I just put my thumb over that so that it thinks I'm wearing it, and then I can be looking at, have it off my head while I run this. So I'm pressing the left trigger and I get the left trigger press message. I bring up my right controller, press the trigger, and nothing is happening. And that's because this XR input is unticked for some reason. So the update wasn't happening. And so now I press the trigger, and yes, now I'm able to see whether either trigger is pressed. And in this way, using these Unity events, it already separates out whether I'm using the left hand or the right hand in a script that doesn't know that it's working with XR. So I could just, if I were to set up keyboard input, I could get calling the same methods and passing information that way. All right, so that's our basic little test set up right there. Next, we'll be going on to get some other inputs. So I could here just copy this line, and instead of looking for the trigger button, I could say look for the grip button, and then have a separate event for grip pressed. But that's getting a little bit messy. We get a bunch of different Unity events. Most of them are going to be blank. So I would like to have a way of just having an array that I can just set in a number of how many bindings I have, and then for each binding be able to pick which button I'm using, and then have Unity events associated with it. And right there, when I'm mentioning that we have a button that we want to specify and a Unity event associated with it, so there's two bits of data that are associated together. That's telling me I'm going to need a helper or a data class below here. So I'm going to go in serializable, and Unity doesn't know what that is right now, so I need to bring in using system, and say public class, and I'll just call this an XR binding. And this is what I'm going to be using for associating a button with a set of events. There'll be some other data that goes into this as well. Now, if you're wondering why I'm using a class rather than a struct, it's because I'm going to be having some methods in here later on. In fact, actually, there's going to be a method right off the bat. So I'm just going to, instead of, I'm not going to need this Unity event anymore, and instead, I'm going to have a serialize field XR bindings. And I'll make this into an array by putting those brackets in right there. I'm going to comment these out since I'll be reusing them down here. And go in here, and I'll just say for each var binding in bindings, binding.update. And so that allows us to just delegate all the logic down to the individual bindings, so that they can look for a specific button. So in here, I'll say public void update, a serialize field, something that specifies what the binding is, and then the Unity event that will be come with it. So I'll get the Unity event right here, and I'll just call this on active. And now for serializing this common usages.trigger button, there isn't really a direct way to get that I know of. So I'm going to create an enum that includes trigger, grip, and all the other things, and then convert between the enum and this value right here. So let's see, I'm going to create a public enum, call it XR button. And here I will just list out all the different button types. So I have a trigger, grip, primary, this would be the A button on the Oculus Quest. Secondary, this would be the B button. I believe on the Vive, the primary is the button that's above the trackpad. I think it's called the menu button. I don't think there is an analog for the secondary. I could be wrong about that. And then also put another setup for the primary touch, since we're working with Boolean values. Secondary touch, just treat that as a separate option. And then also, just to see whether the player is clicking or touching the trackpad or joystick. So primary, I'm going to call this primary 2D axis click and primary 2D axis touch. And now that I have these, I can, in my XR binding, add a serialize field and XR button, button, and that gives me, on these bindings right here, the kind of interface that I want to be working with. So I can have one thing that's looking for a trigger, something else that is looking for the grip, and actually I think I'll just, yeah, and then what happens when they're active. And so for now I can just bring in the debug right here to each of these and have it print to console. So this would be the right trigger pressed, and in the grip, print to console, print right grip pressed. Okay, so that's the interface. Now to actually translate between this button and this enum, I could put the method in here, but there might be other occasions where I want to translate between a button and one of these common usages. So I'm going to create a static class inside of here so that it's universally accessible. So public static class XR statics. And I'll just add to this if there are other XR-related things in the future that I want to be static. And now public static get feature that is looking for an XR button. And now, as for the return type, this I'll need to return this, or actually to return this whole thing. I need to be able to return a input feature usage, and we're looking for whether it's true or false, so put in a bool right there. Okay, and now inside of the static, put in a switch statement for each of the possible buttons. So switch button, and oh right, and I need to actually put that up here. So in the case of the XR button dot trigger, that's just grabbed from right there, I will return common usages dot trigger button. Just exactly, so we're basically just getting this value right here. And so actually I don't really need that anymore. And then I'm going to repeat this line for all the other different cases. So just put some of those in. So in the case of the XR button grip, we'll be looking for the grip button. And what else we have? Primary button, primary touch. Look for the primary touch in the common usages. Again, for secondary button, secondary touch, and what else do we have? 2D axis click. Primary 2D axis click. And finally, the primary 2D axis touch. Okay, so that's a conversion from all of the enum values to actual common usages. Now to actually get it in our update, so this is going to need a reference to that device that we had, or that input we had earlier. So I'm going to look for an input device. I'll just call it device. And to call this in the update, I'll use controller.inputDevice. And then here, we'll just put that logic we had before. Device.try get feature value. And here we'll use our static class, xrstatics.getFeature button, so that's the one that the user specified, and then out is pressed. Okay, and we need to define this is pressed. I'm just going to cache a reference to it up here, so just say bool is pressed. Okay, there we go. And then lastly, this update, I'll just say if is pressed on active.invoke. Okay, so there we go. So we're getting a reference to device, whether it's the left or the right hand, checking whether the feature is pressed or not, and we're getting that by taking the button that the user entered in, passing it through the statics to get a common usages, and that'll change this is pressed to true or false, and then if it's true, then we'll broadcast that. So now if we go back into Unity, on the right hand, we have this trigger and grip messages set up. We'll do the same thing for the left hand just to make sure both hands are working. So add two elements, one for the trigger, one for the grip. You can use different buttons if you want, of course. And just send these into debug. Have both of them print to console. So this one is going to be the left trigger pressed. And then this one will be the the left grip pressed. So now we have four different options. They can be either trigger, grip, left, or right. And we should see all of those be able to print to the console. Now there is an error right here. Not all code paths return a value. Let's see what's going on with this. Right here, so it's, so we need just some kind of default case in case the option that's passed in is not one of the things listed here. So this should be a comprehensive list. If we get a button that is not recognized in this enum, that is a problem. So I'm just going to print out a error message at this point. Default debug.log error and button not found, and just to return back something so the compiler is happy, I will return, I'll just use the trigger button. Okay, and this line here should clear the error we were seeing. Right. Now, if I run this, okay, nothing's happening just yet, and that's because I need to put my thumb over the view so that it's getting the input. So I'm able to get the left trigger pressed and the left grip. I'm going to switch to my right hand, and let's see, not seeing anything yet. Oh, right. Last time I had this XR input ticked off, and I set it in play mode so that didn't get saved. So let's try this again. So with my right hand, got the grip, got the trigger, and the left hand, trigger, grip. And I could easily extend these to get all the different buttons that I could like. All of these should be able to work as to whether they're being touched or not. Now, two things that I want to add still before I finish out this video. One is to have options as to go whether it's press down, press up, or continuous. And another is I want to be able to get the position of my thumb on the joystick, not just whether it's being touched or pressed. So I'll start by getting the different options, whether it's down, up, or continuous. I find it very user-friendly to just set up another enum to give a drop-down. So say public enum, and I'm going to call this a press type. All these begin, end, and continuous. And these would correspond to press down, press up, and press. But I think this naming is a little easier to understand. I'll set up a serialized field, and I'll look for a press type, and I'll just call it press type. And now in my update, after I have gotten set is pressed or not, I can say switch press type. And in the case press type dot continuous, I'll start with that because it's the simplest. Then I can just take this line right here, say if is pressed on active dot invoke, and then have a break. Next, deal with some of the other cases. Case press type dot begin, and I'll just go ahead and copy this line to deal with the end case as well. Press type dot end. These check for a change in state. So if begin happens when we are pressed but we weren't pressed on the previous frame, and end is what happens when we're not pressed on the previous frame and we are pressed now. And we have half of the data we need. We have the is pressed now. So for these, we just need to be able to know whether we were pressed on the previous frame. So I'll need a new Boolean up here. Bool was pressed. And then here are conditions for begin. If is pressed and not was pressed on active.invoke. And then for end is the opposite. If not is pressed and was pressed on active.invoke. Break. There's a lot of kind of extra language here, so I'm going to simplify this down a little bit. I'll just create a little temporary variable right here. Bool active equals false. Just a little something to make this all easier to read. And here I can just say active equals is pressed, and I'll get rid of this. Active equals is pressed and not was pressed. And here active equals like that, just a little less verbose right here. And then down at the bottom, since we'll just combine all of that and just say if active on active.invoke. Okay. All right, next, now the last thing is we need to set this was pressed. So I just say was pressed equals is pressed. So at the end of an update, we'll set was pressed so that we can use it for the next frame. And then when we get here, since we haven't reached this yet, was pressed will still be the last frame, but is pressed is calculated right up here. And so that way we'll be able to compare the current frame with the previous frame. So next, we'll make some use of this. And rather than try all the different possibilities, I'll just go with my left hand right here. I'll just use trigger for all possibilities. Add one more binding. Use left hand trigger, begin, end, and continuous, and left trigger pressed for end, left trigger released, and last here for the continuous, left trigger held. Okay, I'll try this out. Run it. Make sure I put my thumb over the view, and now I press down on the trigger, and I see one left trigger pressed right at the beginning. I get a continuous stream of left trigger held, and when I release, I get a left trigger released. And I'm just going to assume that works for all the other buttons and for both hands. Okay, so one last thing before we're done with this video is getting the joystick. And right now, all we have is whether a button is pressed or not. We're not getting any data from the button, like how pressed it is, or any kind of axis value. So to get some axis value, I'm going to create a new script, and I'm going to call this XR input 2D, because it's kind of an extension of this XR input. So create C# script XR input 2D. And bring this up. And this is going to need a reference to the XR controller. I need to bring in some libraries. Yeah, there are XR interaction toolkit. This one's going to be a bit simpler because there's only one joystick, so I don't need to delegate down to a helper class that I make into an array. So I can actually just put my settings, including the Unity event, right here. However, the Unity event, when I print things out, this needs to be a dynamic Unity event. Unity events by default are just static, where they can call things and you set what the value is right here. That's not going to work for something that's going to be changing depending on the value that it has. So I need to be able to have a form of Unity event that outputs a vector2. So I have a serializable, which means I need to be using system, public, class, and I'm going to call this a vector2 event. And it will inherit from Unity event, but then take in as a generic a vector2, and then open and close curly brace, which means I'll need to be bringing in UnityEngine.events for it to know what Unity event is. Now this is giving me an error right now because I already have a script in this particular project that has a whole bunch of Unity events. This is just a script that I carry over with me from basically every project I work on. Has a vector2 event, but also vector3 event, float event, int event, string event. Basically everything that I can come up with, including lists and arrays passed through Unity events. And so I'd actually recommend, rather than adding it specifically to XR input 2D, other things might want this, so to just create your own script called Unity events, put it anywhere in the project, doesn't have to be attached to anything, and then just add to this as you need it. So anyway, I'm just going to get rid of that here, and now that means I don't need those libraries. So serialized field, vector2 event, and I'll just call this on active. And next I'll have a public void get axis value. One assumption that I am making here is that this script is only going to be running when XR input has detected some kind of touch or press. I could run this in update and just be continuously spitting out zeros whenever vector2.zeros whenever the player just isn't touching the trackpad, and maybe you want that, but I think it'd be a little more efficient to have XR input drive XR input 2D. So yeah, I'll have get access value, and I'm going to assume this is only being pressed when there's some kind of touch happening. So I'll just say in here controller dot input device dot try get feature value, same as before, common usages dot primary 2D axis. So remember, before we used 2D axis click and touch, these just return booleans, so we can see here. This one actually returns a vector 2. So we get primary 2D axis, and then out, and then we need some variable to contain this value that's being modified by the out parameter. To save on memory, I'm just going to cache it here. So vector 2, just call it value. I can set it in this out parameter. And then I'll just say on active.invoke. Oh, one thing that also occurs to me, if you wanted to put this in update and you didn't want to print out a bunch of vector 2.0s, you could just say if value not equals vector 2.0. I don't really feel like I need that with the way that I'm setting it up, but that's another valid option. That is it for this script for getting two-dimensional input. So to hook this up, I'm going to go over into my right-hand controller, and I'm just going to change this binding. So rather than a grip, I'm going to be looking for 2D axis touch and go with continuous. And now, instead of calling this debug directly, I'm going to add a component, so XR input 2D, and have this bring in right-hand controller, XR input 2D, get axis value. So touching the joystick will call this script, which can then call the debug and print to console. However, I want to be able to check, so this string just prints a static value. I want to actually be able to print out the value of where my thumb is on the joystick, so I'm going to need to make a little bit of an addition to this debug script right here. I'm going to print to console and be able to receive a vector 2. So public void, just make an overload of this print here, vector 2, and I'll just call it value, and then inside here just call it self print value.toString. And if you want some precision, by the way, then you can just put in a say an F2 or go with an F4 so that we can get really precise. This is to 4 decimal points. So now let's see if this works. Make sure I have everything set up. This is activated. Oh yeah. Yeah, the last step to set this up is in this print to console, I need to use this new dynamic vector2 print method and also assign this controller. So now I run the game. Put my thumb over the sensor. Bring up the console. I'm going to clear this out for now. So it's not printing anything. I touch the trackpad and now it's printing out zeros because I'm not really moving my thumb at all. I move the trackpad around. Actually, I'm going to collapse this so I can really see all the values. Move this around and I press up to the front and I have close to 0 and 1, go back, 0, -1, here's the left. It also detects if I'm just moving it slightly, I get different values all the way through. Okay, and then just lastly, just to be for the sake of thoroughness, I'm going to do the same thing with my left-hand controller. Add in an XR input 2D and bring in this XR controller and set up another binding. So I'm having all these different options for the trigger, add a 4th binding to get the 2D axis touch. And I could use 2D axis click. That would work basically the same way, except that it'll only print out when I have the joystick fully pressed down. But touch is more likely to be useful. And also when you're using this 2D axis, you're pretty much always going to be using continuous. So now here, instead of going to debug, I will bring in XR input 2D, get axis value, and then the XR input 2D goes to debug and prints to console and prints out the value. Now I run this just to verify it works with both controllers. So left hand, I'm able to see the values. Actually, just make sure of it by scrolling down. Yep, see the values that I'm pressing and only when I'm touching. And same with the right hand. And then I can also get these right trigger pressed, and then with the left hand pressed, held, and released. Okay, and now with that, you have basically a pretty universal purpose XR input system. You don't really need to muck about with all the settings of select and activate and all that kind of stuff. You can just be able to call public methods in your code and have them work however that you want, just with the input taken care of. We've been just running everything through this print to console line just for simplicity. But since, I mean, you could just take any public method and just have this do whatever you like. So that is all for this video. Next time we'll be actually using some of these events that we're passing around to actually do stuff in the scene. But for now, thanks for watching, and if you had any difficulty following along, or would like to just get the end results of these, or you come up with things that you want to contribute, once again, all of this is available on GitHub. It's public. It's under Will9371, that's me, and character template. And there'll be a folder for XR, which has all the scripts and materials that we were just working on and the interaction test scene. This will be updated as I add new things. And also, while you are here, there is lots of other things inside of this particular project. I'm just kind of using it as a repository for a lot of personal libraries that I feel are fairly well established and worth sharing. The main thing right now is under character. We have a physics-based first-person character, third-person character, a AI system in here that can follow you around, and lots of other things. So you should absolutely check that out. But until next time, I will see you in the next one.